to say good morning, everybody, which it is for me, but I guess we're in the afternoon now. So good to see everybody. It was exciting to hear all the speaking that was happening this morning, and it's definitely an exciting area. I don't know if you've noticed, but everyone's talking AI, AI, AI. You know, AI can solve all the world's problems. But you know, when I go and I talk to customers, I always get the same question. I just came back from Cisco Live not too long ago, and they said, "Well, how is AI going to actually solve my network problems?" And so now you have to get a little bit specific on what it can do and how we can apply it. And so it was great to hear from Chris. And in some ways, you can say, well, AI is the problem. You know, it's going to drive all this additional traffic over the network, and we're going to have it distributed, and we're going to have it at the edge. And so it's this new use case. In another sense, AI becomes the answer, right? And we can apply it in an operational way. So let me go ahead and dig right in. So how do we digitize countries? How do we drive productivity? How do we do more automation, make the building smarter, make the home smarter? Well, the answer to that is wireless. We do it with wireless. And we experience this every day. You know, when you get up in the morning, what do? You're on your Wi-Fi network. When you go out and get in your car or you head for the train, what do you often do? You go to 5G. When you get to the place you work, what do? You go back on Wi-Fi. And you go to these different areas and you go to these different venues. And what happens? You move between these different technologies based on the thing that you're trying to do for this sweet spot of what that particular technology is capable of doing. So a lot of times, and Chris said it at the end there, a lot of times we say, well, is 5G going to take over most of the use cases? Is Wi-Fi going to take over most of the use cases? I would propose that we are completely dependent on both. And we have to improve these as we go forward. And we have to improve how we would pull them together and how they would converge. You know, if you go to an airport today, or if you go to some location where there's a public Wi-Fi, and you go to connect to the Wi-Fi, and the Wi-Fi is really bad, what do? You go into your connection manager and you turn Wi-Fi off. So how we choose our path, how we go to Wi-Fi and how we go to 5G, we're often figuring that out ourselves. We put that burden on the user. We put the burden on the user? Really? Isn't there a better way to converge? Isn't there a better way to digitize? How do we tie these two technologies together? And you know what? These technologies, like I was mentioning earlier, they have strengths that are really the same in some ways, but they're very different in others. If you look at 5G, 5G is great when you're going 120 kilometers down the highway. You're not going to use Wi-Fi for that, right? And you can see some of the differences on this slide. You know, when it comes to speed, the mobility that you can do with 5G, that's really the domain of 5G. When it comes to efficiency per bit, how much power does it take to transfer a bit? Now, it turns out these technologies are pretty close when it comes to transferring a bit, but why? Well, 5G might be going 1 kilometer, 2 kilometers to hit that cell. They spend a lot of effort in order to optimize that so that you can get a full day's use out of that battery. With Wi-Fi, it doesn't have to go 2 kilometers. In fact, it's probably going meters. So 5G has a benefit in certain circumstances that Wi-Fi can't do. But you know what Wi-Fi can do? It can move a lot of traffic really fast. And what do 5G operators need? They need densification. They need the ability to move more traffic as that demand goes up. We saw some slides earlier today. Demand is going up. In fact, in some cases, it's even going up exponentially. So we've been trying to converge these technologies for a very long time. And over the last 20 years, Cisco and some of the other companies out here, you can see the various architectures that the various companies have put together to converge these technologies. Do you know how much of these different technologies have been implemented today for converging Wi-Fi and 5G? That. That's the EPDG. And you know what that does? That does Wi-Fi calling. That's the one convergence area that's been successful. All this other money we spent on these different technologies and how we pull them together, guess what? They're still separate. There's still two separate complete organizations out there. IEEE, 3GPP, right? And so we get into these mindsets where one has to win over the other. I would propose that one doesn't have to win over the other, that the other is the answer to the first. Does 5G solve a problem that Wi-Fi can't do? Does Wi-Fi solve a problem that 5G can't do? And can we converge these technologies together? So can we use AI to converge? And can AI do a better job than humans have done over the last 20 years in bringing these technologies together? And so, you know what? I think there's a real opportunity here. So if you look at how do you use AI and you look at spectrum as a problem, what is spectrum? How is spectrum actually allocated? It has to do with location. It has to do with things like country boundaries. So the regulators in the room, they're specifying how spectrum can be used, how much power can use, and it's done based on that location. If you have an incumbent like we do in 6 gigahertz, that incumbent is in a specific location using specific frequencies, and so we have to avoid it. So the location becomes important in how we use that spectrum. We have differences in indoor and outdoor. In 6 gigahertz, we developed a technology, it's called LPI, low power indoor. So again, it's based on where it is. You can use that spectrum if you're indoors, you can't use it if you're outdoors. And so we have these different technologies for separating out the spectrum so that we what? So that we don't interfere with each other. And so that both technologies can get the best experience. There's even new conversations that are going on around VLP and C2C technologies, these peer-to-peer technologies, and how much power should they have and how much would they interfere with current uses of the spectrum. And guess what? That's based on location too, because if you want to use that, you have to protect the incumbents. And so what do? We talk about geofencing. So location has become this way that we separate out the different spectral use cases. But can we use location and AI to actually improve spectral use? So we have this tendency to want to separate everything out. But can we do this more intelligently based on the demand and the patterns and how people are actually using that spectrum? In fact, location services have become ubiquitous. How many people use Google Maps or Apple Maps? Location is fundamentally pretty much solved outdoors. You know where the real location problem was? Indoors. Trying to figure out where people were indoors. Do you know that every Wi-Fi chipset now contains a technology called FTM, fine timing measurement? And that fine timing measurement can, guess what, get location very accurately. Here's some of the technologies that are happening indoors today. We had older technologies that were only accurate to meters, things like triangulation between different APs, measuring things like power and things like that. But now what we're doing is something similar to GPS. We're measuring time of flight. That's what FTM does. And if you measure time of flight, even if you go through walls, the speed of light doesn't change. So you can get very accurate triangulation. FTM can give you accuracy down to a couple meters. And there's a new technology out there. It turns out, and I won't get into all the technology behind it, but it turns out if you use a very wide channel, which by the way, we're adding wide channels, aren't we? When we go into 6 gigahertz, if we have the 1200 megahertz, we can do wide channels. The wider the channel is, the more accurate the location can be. Now there's another technology out there called ultra wideband that's going into a lot of the chipsets today. And guess what? That can get accurate location down to less than 10 centimeters. So we know where people are and we know the uses of the spectrum based on that location. So AI is very data hungry. AI is only as good as the data you feed it. So how do we get that information to that AI engine? And so if we know the RF characteristics of where each user is, as well as the APs, the cells, et cetera, then we can determine how that spectrum is currently being used. And if we know exactly how and where that is being used, we can feed, guess what? AI. And then based on that intelligence, we can allocate the spectrum in order to optimize your overall experience. Now, it turns out in Wi-Fi and unlicensed, we've been doing this for a very long time because it's unlicensed. And because it's unlicensed, when we're inside a building, there can be multiple uses of that spectrum. So what do? We do an algorithm. It's called radio resource management. And if, in order that we can use all the latest buzzwords, we call it AI RRM now, because we're learning about the environment and how the spectrum's being used. And so what do? We map our channels across the APs and the power levels so that we can ensure that we get good coverage and that there's no dead spots, while at the same time maximizing the overall throughput of the network. And if we do that, what does it mean? It means that the device can transmit with less power, green. It means that we have coverage no matter how we move or where we move. Now, this is moving that location intelligence to the edge. If we're pulling this information right out of the device, then we have much better resolution than we would have had if we had not pulled it out of the device, right? And so what you can see now is not only do you have these propagation maps based on how the APs see APs, but now you can see actual user experience and how they're using the RF based on the applications that they're running. So optimization, by using the data that's coming from the devices, we can improve radio resource management by 25, 30 or more percent. 25 or 30 or more percent. Now, what if we're optimizing that between the use of unlicensed and licensed? So you know what? Most 5G devices also have Wi-Fi. Most of them are multi-radio devices. And so it turns out that if we're pulling in information from the device, not only do we see all the areas of interference that we're getting, not only do we see the propagation that's happening with Wi-Fi, but we're seeing the propagation of 5G. We can see how the 5G propagates through the building or doesn't. So now if we have the Wi-Fi propagation and we overlay that with the 5G propagation, guess what we know? We know where the edges are. And if we know where the edges are, we can predict, based on how you're moving, how to hand off seamlessly between two completely different technologies. So instead of the user having to pick which one they go to based on their experience, the intelligence of the system will do that for it. And not only will it do it for it, but it will optimize it. What if the Wi-Fi is very heavily used because there's something going on in a stadium? We'll move some of that traffic to 5G. What if the 5G is heavily used? Move that traffic over to Wi-Fi. And so what we can do then is we can use AI to learn how the traffic is moving based on demand. So now we can dynamically allocate channels based on the demand at that particular time, that particular day, that particular use. We do the Wi-Fi at Mobile World Congress at the Fira de Barcelona. And, when we prep that network, we go in and we measure all the RF conditions. Well, guess what? The RF conditions are very different when we're doing it the week before than when the show actually starts and they put up all those booths and you have about 100,000 sacks of water walking around, otherwise known as humans. That changes the RF characteristic. So you have to be able to react to these things in real time, right? And that's how we can apply AI to doing some of these things. And now we can do this intelligent path selection, but not only can we do intelligent path selection, but we can intelligently load balance across these technologies. So one other example, in this case, I'm showing a technology that Cisco's playing around with in our labs. It's called vector roaming. And what vector roaming does is it takes into account the location of a particular person, individual, phone, thing, and as it moves across and around the building. And what we can do then is we can learn all the movement patterns through that building. Because you know what? People don't walk through walls, they don't walk through desks, they walk down and they walk in certain patterns. And if you know that people are moving in certain patterns, guess what? You can predict where that next handoff is going to be. And you can make that handoff very good. Not only can you make it very good AP to AP, but when you walk out of the building, what happens today when you're on Wi-Fi and you walk out of a building? It tries to stay on Wi-Fi. The device desperately tries to stay on Wi-Fi, right? And so what happens is that you go out and you go into 5G. Well, the Wi-Fi network is saying, oh, check out these other neighbor APs, try to move to these other neighbor APs. There are no neighbor APs. You went outside. So now what you can do is you can say, hey, I know how you're moving and I know the patterns. We've learned these patterns. Don't try to stay on Wi-Fi. Go to 5G. And it's the same thing when you walk in a building. Don't try to hang on to 5G. Go to the Wi-Fi. There's a good Wi-Fi network in this building and it's offering all sorts of capacity. And so we can learn these types of things. Now, how many times, if you have some of these automated services that automatically connect you to Wi-Fi and you're driving down a street, or sometimes you're walking down a street and you get these pop-ups if you tell your device to automatically connect, what happens? You get these offers. Hey, do you want to connect to my Wi-Fi? Do you want to connect to my Wi-Fi? Do you want to connect to my Wi-Fi? Right? And that's a nuisance. The only time you really want to connect to the Wi-Fi is if you're going into the building. If you're just walking by, you probably don't want to connect to the Wi-Fi. You can just stay on the 5G. Well, if you know through location services how that person is moving and they're moving adjacent to the building, even if they see the Wi-Fi, don't connect. But if they vector off into the building, now connect. So this type of intelligence, how people move through a building, can be leveraged to how people move things, trucks, cars, move through a city. And if you can get these vector maps that show not only how you move through a building, but through a city, then you can get these for how people move around a country. And if you can understand that, then you can apply AI to learning what kind of spectrum you need in what situation, depending on where you are and when it's happening. And then you can react as that demand changes. Because you know what? The traffic is going to go where the traffic goes. But we can massage these systems to better carry it based on the dynamic nature of the need as we move indoors, outdoors, and across the planet. So I would like to just sort of wrap up and I would say, look, we need both of these technologies. 5G is the answer to Wi-Fi coverage. Wi-Fi is a hotspot technology. Wi-Fi is the answer to 5G densification. It's very expensive to put in more cells, but there's Wi-Fi everywhere. And where it is where connection happens. That's why it's called a hot spot. That's why we called it that. So Wi-Fi is the answer to cost-effective densification and how we get capacity. And AI can solve how we move across these. So that's what I wanted to present. I wanted to talk a little bit more operational. I wanted to give you some hard examples because I know sometimes we talk about all these grandiose things happening in the future, but look, there's real and practical ways to use this technology to solve this problem.